Hi, slipcor here. Welcome to my first devlog update. This month we will get into the MiniGolf game I am coding, and let us launch the game and check what we have so far. We rotate the camera around the ball with sideways movement. With the left mouse button we enter the gauge mode, selecting our shooting power. Note how the gauge has persistent power if we exit the mode by releasing the mouse button. It should start fresh, so let's open the physics board blueprint and check it. We navigate to the showing and hiding function. And here to the showing of the widget. I tried to add a resetting of the gauge value. I wanted to use the function I created inside the power display class, set power display. Put it in place. Connect the execution node, compile it, let's see. Sadly, this did not fix the issue. Let me show you what I did. After a little bit of thinking, I decided to set the stroke power. Pull the variable over and select set. Default value is 0. That is fine with me. I never updated the actual stroke power, and this value was unchanged throughout releasing of the mouse button. So when showing the widget, it still had the last power saved. So the proper fix was just dragging out the set stroke power to 0. Now I wanted to add an impulse to the ball, just like the jump does. But it should be directed at the direction the camera is looking at, right? So I grabbed the ball reference, and how did we do the impulse thing again? Let's have a look. From the ball instance, we drag a node out to help us find add impulse. So I connected this add impulse and tried to get a way to get the direction of the camera. By accident, I got the camera reference, and from there I could find a function to get its location. As there was no direct direction accessible, I had to reconstruct one. So I went ahead and got the ball's position, and then I tried to get a way to find the pointer from the camera to the ball, which I did not find. I then went the basic route and subtracted the camera position from the ball position, which does return the difference from the camera to the ball, logically pointing in that direction too. I tried looking for a split into axis function and ended up with the break vector function. Up next, putting this back together into a vector. Obviously we need to change this up a bit because we do not want upwards movement, only movement in X and Y. Hang on, what was the coordinates in 3D? Yeah, okay, X and Y were correct, but somehow it does not seem to give an actual impulse. Or does it? It could be imagining this. I remember the impulse to jump being really high, so maybe let's try to applying this jump impulse now. Let's do this by dragging the jump impulse variable into this. So drag a vector multiplication and feed it with the jump impulse. Now I drag the result to the add impulse input, and let's check it out. Well, this impulse is definitely visible. Behind the scenes, I changed the value to something way smaller. I think in the 3 digits instead of like 350,000 something. The impulse works, but the ball does not stop rolling. For now, let's continue with the stroke. There we go, it was 100. Now let us add the factor to the stroke power. Testing this showed again that something about the values is way off. What could it be? Halving the value might be a sensible thing to do. Let's try it. Yes, that was the last thing I did, so continue on the next day. I tweaked some values, namely friction and restitution, aka bounciness. I set both to 0.5. So increased bounciness and reduced friction. Testing this showed that this looked and felt a bit more like a golfing game, before the ball acted more like a water ball type of thing. Next, I wanted to further restrict the jumping. At the moment, it is only showing the bar when the velocity is below a certain threshold. So the same should apply to the hiding, right? I copied the logic and applied it to the release method. Then I wanted to add a zoom function, so first I had to add an input method, edit, project settings, and the action mappings are for linking one single key to an event. Axis inputs are better suited for events that have multiple directions, back and forth, up and down, and so on. So I added a new axis, calling it zoom axis. Then I added the mouse wheel axis so that we get a direct linking between up and down. However, I noticed when trying to add gamepad support that there is no exact axis representation that is not used already, so I changed my mind and added the zoom functions to the action mappings. So, adding zoom in, calling it with mouse scroll up, and adding zoom out, calling it with mouse scroll down. For the controller setup, I went with the D-pad, so up for zooming in, down for zooming out. To implement the event, right-click in the event graph and type the event name, in my case, zoom in and zoom out. I selected the important asset here, the spring arm holding the camera. The only thing I need to do is change this value. This will basically result in a zoom function, so let's do that. Let us drag the instance into the blueprint so that we can access its variables. At the end of this function, we want to set the target arm length, so let us set the value and think about what it should be next. Right, if we zoom in, we want to decrease the arm length so that the camera gets closer to the ball. We also want to make sure that the length does not go below a certain point, so we use the max function and it will thus never go below 100. When zooming out, it's the other way around, so increase the arm length and use the min function to never go above a certain point. Let's just take 2000 for a start and see how this works out. Like this, it will not work out at all because I forgot to actually feed the initial first target arm node with the spring arm instance. So let's do that, drag the instance out again, recompile and check it out. I think this looks pretty good. I will think about tweaking this, but for now this is okay. Nice, moving on. So the final thing I will show you today is how I added the visual direction indicator, which is basically a cylinder. So adding it to the mesh. I actually did not give it a mesh, so I had to select a mesh in the static mesh category. I selected the cylinder. Then I changed the scale to be very thin, factor of 0.01. The setting in here is important for the cylinder not to cause collisions in case for some reason it may persist. Testing this, yep, it does stay in place, not collide, it does not interfere. About the code side, I obviously have to show hide and expand and retract the cylinder. It would make most sense to hook this into the power bar functionality, as it basically always comes and goes with it. Let us first create events that we then call. I called them update power indicators. Maybe later I have more than those, so let's do that. Let us add a parameter to set it to. It should be of type float, and preferably take the percentage from 0 to 100. First, we update the power bar display, which conveniently already takes in a float. Then we replace the initial calls to this power bar display thing with the new function. Now we get the cylinder reference and set its scale relatively based on the input float. Let's see how this pans out. We need to get a vector, make vector, and we set the Z scale to the percentage we got from the stroke strength. Finally, calculate the actual percentage by multiplying it with 0.08 and set the X and Y percentage to stay at the 0.02. This should give us a nice cylinder that makes sense. Let's have a look. Apart from the fact that the cylinder stays in place, this looks promising. Finally, let us hide the cylinder when hiding the power bar. This way the indicator will also vanish as the stroke power is set to 0. This seems to work. Let's call it a day. And I will see you in the next dev log. I am planning to release those in 10-minute chunks, so this will have to wait until I finish 10 videos of footage. No idea when this will be, so see you then. Bye.